So today we're going to be looking into the patterns, sequences, and series. Alright, so I'm going to be showing you how to use the different kinds of equations or formulas that you're going to be given, how to calculate whatever it is that is being asked, and how to manipulate those formulas to get whatever it is that you're being asked to do. So the first thing that we're going to be looking into today is your arithmetic sequences. Alright, so the important thing that you have to know about an arithmetic, it is the fact that it has a common difference. Okay, it is a common difference. So for example, let's just say you have 1, 2, 3, 4, 5. So as you can see that the difference here is just going to be common, because 5 minus 4 it's 1, 4 minus 3 it's 1, 3 minus 2 it's 1, 2 minus 1 it's also 1. Alright, so you can see that the difference is quite common. So again, you might be asked to find the general term. Now this is how you find the general term. This is equals to A plus Tn minus 1 multiplied by E or D, wherein which your A is your first term. That being 1 in this case, for example, and then your N, that is going to be the number that you're going to be looking for, and then your D is going to be your difference, right, which is 1 here, and this is your nth term. All right, so now as you can see that your difference is, this is how you get your difference, right? T2 minus T1, which is the same as T3 minus T2, right, which is equals to 1 in this case. And then you might also be asked to calculate the sum. That's what that, yeah, the sum, and this is how you do it. Just n over 2 and ta plus l, which is your last term, but this is the same as saying, sorry, n over 2 to 2a plus into n minus y multiplied by d, where your d is your difference, your a is your first term, your n is the nth term, whatever n term it is that they want, and stuff like that, and then you will get your answer. So for example, if they say the third term, the third term, so you're just gonna put 3 here on n, so it's just gonna be 3 over 2 into 2 multiplied by a, which is your first term. In this case it's 1 plus into 3 minus 1 multiplied by the difference, which is 1 as well, and then you're just going to get you your sum of terms. Done. That is the quadratic patterns or sequences. Okay, so now the first thing that you have to note about a quadratic pattern is the fact that it has a constant second difference. Okay, very important to note that the second difference, not the first, not the third, but the second difference is constant. Now what do they mean by that is, for example, let's just say we have, okay, T1, T2, T3, and T4, okay, maybe and T5, right? So this is going to be their difference here, right? And then let's just say, okay, this is going to be T2, T2 minus T1, right? This is going to be T3 minus T2. This is going to be T4 minus T3. It's going to be T5 minus T4. All right. So now this is your first difference, right? This here. This is your first difference. And then now this is your second difference. So now this is to say that with your second difference, for example, whatever value that you get here, if you say this value minus that, for example, let's just say you get 2. When you say this value minus that, it should give you 2, throughout. If it doesn't give you 2, then you can rest assured that this is not a quadratic pattern, okay? So remember that your second difference should always be constant, not the first, but the second difference. Alright, and then we have our general term formula, and our general term formula is as follows. Tn is equals to an squared plus bn plus c. Alrighty. Now, obviously you might be asked to find your A, you might be asked to find your B, you might be asked to find your C, or whatever. So it's important to note here, this is how it should be all the time. So here, you are going to have 2A being equals to this, right? Then you're going to have 3A plus B being equals to that, yeah? And then you're going to have A plus B plus C being equals to that. All right. Now, this means that if you have to find your A, if you have to find your B, if you have to find your C, you're just going to go straight into your pattern. So for example, let's just say we were, okay, so let's just say here, for example, let's just say here we had 4. And in here, let's just say we had 1, for example, all right? Because these are what we're going to be working with. And so for example, you wanted to find your general formula. You wanted to see what is your C, you wanted to know what is your B, you wanted to know what is your A. So what you would do is, now you would say, so 2A is equals to what? Our common difference is 2, is equals to 2. You would divide by 2, you would divide by 2, therefore your A is equals to 1. Alright, then now, this is what you would do. Your original formula would, so this is 1, this would just be n squared because there's 1 here. Okay, and then let's just say maybe you wanted to find B, so now you'd say 3A plus B is equals to 4. We know that your A is 1, so therefore it's just 3 multiplied by 1 plus B is equals to 4. So now we have B being equals to 4 minus 3, which is equals to 1, so therefore our B is 1, which means you're going to have plus 1 again, so it's just going to be n because our B is 1. So now when I find the C, so we would say A plus B plus C is equals to, you see, 1. It's equals to 1. So our A is 1, our B is 1, our C we don't know, right? 1 plus 1, which is 2. 2 plus C is equals to 1, so therefore C is equals to 1 minus 2, which is equals to negative 1. So therefore means your C is negative 1, which means we have a negative 1. You see? So now you would have found your general formula. And then you can calculate anything. They could ask you to calculate the third term, and you're just gonna say third term is equals to, then you just substitute here by putting a 3 squared plus 3 minus 1, and then you're just gonna find your answer. You see? So the most important thing is understanding how do you find your A, how do you find your B, how do you find your C, and how to actually see that this is a quadratic number pattern. and then therefore, then after that you are done. Terms, right? So now for the sum of terms, this is the equation that you are going to use. It's going to be same, which is equals to a to r to the power of n, right, minus minus 1 over r minus 1. All right, this is the first one. Now we only use this one if and only if your r is greater than 1. Okay, so then there's a second one, which is as follows: a into 1 minus r to the power of n over 1 minus r. So now we only use this one only and only if your r is less than 1. So if you get this constant here, and you find that maybe it's 0.005, that would mean you're gonna use what? This formula for your sum of terms. And if now your common ratio is greater than 1, then you're gonna use this one. Okay, and then lastly, we might be asked to calculate the sum of infinity. Ooh, sorry, using a wrong pen. Okay, sum of infinity, and this is going to be your formula: a over 1 minus r. Okay, so now this is also the same as when they ask you to calculate if it is convergent or not, right? If they ask is it convergent or not. So now what they mean by that is the fact that you have to now find a range. Okay, you have to now find a range. So for example, let me just show you this. So now here, how do you see if something is if it is convergent or not? Right, so it means now your sum of infinity, as you plot them, right, as you plot, you will see that it will go like that. You see? So for your convergency, how we test if either maybe this pattern is convergent or not, your range must be between a -1 and 1, meaning your common ratio must be less than 1 but greater than -1. All right, that's how we prove if it is convergent or not. And if it is within this range, then that would mean it is convergent, and if it is not, that would mean it is non-convergent. Now, on our first example, it reads as follows: given the arithmetic sequence where you have 3, x, 11, and y, determine the values of x and y. Now, as you can see, I have highlighted this in a green pen to basically show you that each and every time you're told that this is an arithmetic sequence, you need to take advantage of that. What is it that you know about an arithmetic sequence? You know that the difference of an arithmetic sequence is what? Is constant. So therefore, you don't have to stress yourself. All right. Okay. So now we want to solve for x and y. All right, let's go. So you have 3, you have x, you have 11, and you have what? Y. All right, now let's go ahead and find the difference. Okay, it's x minus 3, it's 11 minus x, it's y minus 11. All right. However, we do know that our first difference is what? Is constant. So therefore, which means that x minus 3 is the same as 11 minus x, right? This is the same as that and that. All right. So now in this case, what we can do is we can just solve for x, right? All right. So now I'm just going to transpose this x to that other side, which is going to give me 2x is equals to 11 plus 3, which is going to give me 14, right? 14, and I have 2x. So I'm going to start dividing now. Right? Right? X is equals to what? Is equals to 7. Easy stuff. All right. Now that I have solved for my x, now I can solve for my y. All right. Okay. So I'm gonna say 11. So I'm gonna say, sorry. So I'm gonna say x minus 3 is the same as y minus 11, right? X minus 3 is the same as y minus 11. Why? Because I know that this is an arithmetic and therefore it has what? A constant difference. I don't have to stress myself. All right. So now, but because I have solved for my x already and I know that my x is what is 7 minus 3, which is equals to y minus 11. 7 minus 3, which gives me a 4, y minus 11, 4 plus 11, my y is going to give me what? 15. Done. Easy peasy stuff. Okay, so on our next question, we have to determine the sum of the first 24 terms. As you can see, I've marked it green, 24. All right. Now remember the formula for determining the sum of the nth term is like this, right? N over 2 multiply by 2, a plus into n minus 1 multiplied by d. I'm sure you have this formula on your textbook. Okay, so this is going to be 24, right? 24, which is equals to, okay, 24 terms over 2 multiply by 2, and then our a, which is that one, the first term there, which is 3 plus our n is 24 minus 1 multiply by the difference, which is 4, right? Remember how we got the difference from the previous question where we solved for x and our x was 7, and then we said 7 minus 3, we got what? 4. I hope you still remember that. Okay, then this will give us 12 multiplied by 3 times 2, which is 6, plus this is 23, so this is 23 times 4. Okay, and then you just punch it on your calculator. I'll give you a minute just to punch this into your calculator, and our final answer, my final answer, is 1176. That's it, easy peasy. If you got a different answer, don't forget to comment below. So our next question is as follows. Given the sequence of 4, 9, 14, and 19, determine the first term in the sequence that will be greater than 2017. All right. Now the first thing that we need to do here is to remember this formula. We have Tn is equals to A plus into n minus 1 multiplied by d, which is the difference, right? And we know that our difference is basically T2 minus T1, which is the same as T3 minus T2, right? Because it's an arithmetic sequence, so the difference is constant. All right, so our T2, which is 9 minus 4, which is the same as 14 minus 9, which is 5. So our difference is 5. All right, so now we have Tn, which is equals to, what is our first term? Okay, let me just write it here. Okay, just say Tn is equals to our first term, which is 4. So it's going to be 4 plus 2n minus 1 multiplied by our difference, which is what? Which is 5. Okay, so we have 4 plus 5 multiplied by n, which is 5n, minus 5 multiplied by 1, or negative 1, which is negative 5. So then 4 minus 5, which will give us a negative 1 plus 5n. Alright, so now this is our formula. Okay, so now, however, the question is, what is the first term in the sequence that will be greater than 2017? Okay, so now back into our formula. I'm gonna say where our nth term, which is going to be 2017. Alright, 2017 is equals to negative 1 plus 5n. Alright, so we're going to transpose this one, which will give us 2018, because 2017 plus 1 is equals to 2018. Alright, then we're going to divide by our 5. Our 5. Therefore, our n is equals to 403.6. Now, you don't just write this and leave it like that. We have to substitute and see if it's greater than 2017. How are you going to know that it's greater or less than 2017 if you do not substitute? All right, okay, so now roughly on the side, you're just going to do a quick substitution to just check if 403.6 is the right is correct or not. All right, so now we have we know that our formula Tn is equals to negative 1 plus 5n, right? And remember, this has to be greater than 2017. Okay, so negative 1 plus 5, substitute by 403. Remember, 403 is this, right? Okay, this is going to be our first substitution, and then on our second substitution, it's just going to see negative 1. Sorry, let's just start with one substitution and then we'll see. All right, so 5 multiplied by 403, we get what? 2015. All right, negative 1 plus our answer, which is 2014. All right, so we get 2014. Okay, so whenever our n is 403, we get what? 2014, and 2014 is not greater than 2017. So therefore, which means 403 is not correct. All right, so now I'm gonna try rounding it off. Just gonna try round, so we know that this is not it. Just gonna try rounding it off. Plus 5n, negative 1 plus 5, 403. Round this off. This will give us 404. And then you're gonna calculate 404 multiplied by 5, negative 1 plus answer. We get what? 2019. Now, is 2019 greater or less than 2017? Of course, it's what? It's greater than 2019. So now, this means that our nth term, our very first term that will give us, that will be greater than 2017 is what? Why am I using a blue pen? I'm supposed to use a green pen. N is equals to 404. Bingo. There goes your answer. See? Easy peasy. Okay, so now our next question says, given the geometric sequence, which is 2, 2 over 3, and 2 over 9, 1. Determine the general term for the sequence. And then secondly, is the geometric sequence convergent? Alright, so for our A, so now we know that this is the general formula of a geometric sequence. Tn is equal to AR to the power n minus 1, which you have in your textbooks, where A is your first term, and in this case, which is 2, and your common ratio, which is the same as T2 over T1, is equal to T3 over T2, and in this case, which is going to be 2 over 3 all divided by 2, which will give you 1 over 3. Okay, so now we go back to our original formula, where in which we substitute. T is equals to A is our 2, R is 2 over 3, and minus 1. That's it. And the next question is the geometric sequence convergent or not? Okay, so now this is how we check the convergency. All right, so if our R is less than 1 but greater than -1, then that would mean our sequence is convergent. However, if it doesn't range, if our R is not within this range, then it means it is not convergent. Now let us see if our R is, so our R is 1 over 3, right? And we know that 1 over 3 is less than 1. However, 1 over 3 is greater than -1. So therefore, it is convergent. Easy as that. So our next question reads as follows. Solve for P if 3 to the power of P is equals to the sum of infinity. So now in this case, we need to make use of our formula of sine of infinity, which sum of infinity, which is A, which is the first term, over 1 minus R. Okay, and then from there, we just substitute. What is our first term? Our first term is 2 over 1 minus. What is our R? Common ratio, which we've calculated previously, is 1 over 3. And then it's going to give us 2, 1 minus 1 over 3, which is 2 over 3. This will cancel that, and we will get 3. Right. So 3 to the power of P is equals to what? It's equals to 3, right? Which is what we've just calculated. And remember now that when the bases are the same, remember what happens. So P is equals to 1. Why? Because our bases are the same, so we just take the exponents. So the next question says, given the series, which is 2x plus 1 to the power of 1 plus 2x plus 1 to the power of 2, etc., etc., as you can see up there, Determine the values of x for which the series will converge. Okay, so there's two things you need to note here. First thing is you need to identify whether that is a geometric, arithmetic, or quadratic. And so it might look a bit complicated because there's 2x plus 1, but that's really nothing to worry about. In this case, you might as well just take this whole thing that is inside a bracket as x. So for example, it would have been x to the, let me just use a different color because this is just an example. So it could just be x to the power of 1 plus x to the power of 2 plus x to the power of 3 plus x to the power of 4. And you can see that when you say x squared divided by x to the power of 1, we get x. And when you say x to the power of 3 divided by x to the power of 2, you get x. Same for the others, right? So now this should tell you that this is a... Alright, now let's get to it. So the first thing that we need to do is to get our r. And for us to get our r, we know that it's t2 over t1, right? What is our t2? It's 2x plus 1 squared divided by 2x plus 1. Alright, and this is the same as 2x plus 1 multiplied by 2x plus 1 divided by 2x plus 1. And then this will cancel that. We are left with what? 2x plus 1 over 1, which is the same as 2x plus 1. So that is our r. And we remember that for convergency, we know that our r should be less than 1, but greater than what? Negative 1. Okay. And so our r is what? Our r is 2x plus 1. Right. And then now, what we're going to do is we're going to transpose that positive 1. So you're going to transpose this positive 1. So if you transpose it to that side, it becomes what? It becomes negative 1. Right? And when we transpose this positive 1 to that side, it becomes what? It becomes negative 1. So which means we have negative 1 minus 1, which gives us what? Gives us a negative 2. 2x. And then we are left with 1 minus 1, which gives us a 0. And then from here, we're just going to divide by 2, divide by 2. This 2 will cancel that 1, and we're left with what? Negative 1 x 0. So now this is your final answer. So x, for which values of x will the series converge? So the series will converge for the values of x that are less than 0 but greater than negative 1. Question B says, determine the sum of infinity if x is equals to negative 1 over 4. Now you remember when we did the convergency, remember that now negative 1 over 4 is within that range that we had previously stated. So then it definitely does show that this whole series is convergent. Okay, so determine the sum of infinity if x is equals to a negative 1 over 4. We know the formula that we need to use for this is sum of infinity is equals to a over 1 minus r. Okay, and we know that a, which is our first term, is 2x plus 1 divided by 1 minus, what is our r? Our r is 2x plus 1. Right. Now in this case, we're told that if x is equals to a negative 1 over 4, So meaning where there's x, we will substitute with negative 1 over 4. So we have 2 multiplied by negative 1 over 4 plus 1 over 1 minus 2 into negative 1 over 4 plus 1. Okay. And if we say 2 multiplied by negative 1 over 4, we get a negative half plus 1 divided by, that one will cancel with that one, so we'll be left with negative 1 over 2, because we'll be left with half there. Alright, and then negative half plus 1, we get a half, altogether divided by negative 1 over half, which gives us a negative 1. Alright, easy peasy. So but what you can do is you can just punch in your calculator. I just wanted to make sure that everything is in line, but you can just punch in everything into your calculator and just write your answer as it is. There's no need for you to plus and minus using your own head. And our last question is given the quadratic pattern of 3, 10, 19, etc., etc. Now determine the next 2 terms of the pattern. All right, how do we do that? Let's get right into it. Okay, so now we have 3, we have 10, we have 19, and we have this that we don't know, that which we don't know. Okay. All right, now 10 minus 3, we get 7. 19 minus 10, we get 9. Okay, 9 minus 7, we get 2. All right. Okay, so for the sake of peace, we're just gonna call this x1, and then we're just gonna call this x2. Okay. Okay. So now we know that 9 minus 7, we got what? 2, right? So then therefore it means x1 minus 9 is equals to what? 2. Because this is a quadratic pattern and we know that this difference should be constant. So we know that it should be 2 here, right? So therefore x1 is equals to 2 plus 9, which is 11. Therefore it means my x1 is what? My x1 is 11. Same applies with my x2. Okay, so it's x2 minus 11, which will give me a 2. All right, now x2 is equals to 2 plus 11, which is 13. All right, meaning my x2 now is what? 13. Okay, so if I say 3 plus 10, no, sorry. If I say 10 minus 3, I get a 2, right? 10 minus 3, I get a 7. 10 minus 3, I get a 7. 19 minus 10, I get a 9. You see? So this, which I'll just call y in this case. Y, this is going to be z. Y minus 19 is equals to 11. So y minus 19 is equals to 11. Okay? The same applies with z. So it's going to be z minus y is equals to what? 13. All right. Now y minus 19 is equals to 11. therefore means y is equals to what? It's equals to 30, because 11 plus 19 will give us 30, right? So now that we know that my y is what? Is 30, I'm just gonna put 30 here, you see, and then therefore means my z is equals to 13 plus 30, which will give us 43, and my z is 43. So you've gotten your two terms that you were looking for. So therefore it means my T1, 2, 3, 4, my T4 is equals to 30, my T5 is equals to 43. See? Easy peasy. There goes your 2 marks. And then moving right along, B says determine the nth term of the pattern. Alright, before we can determine the nth term of the pattern, it's important to remember this. Where am I going to write it? 2a is equals to that. And 3ab, a plus b is equals to that. Okay, and a plus b plus c is equals to that. Just to make it easier for you. Okay, so now we are set to determine the nth term of the pattern. So what they mean by the nth term of the pattern, this is basically what they mean. Remember this formula. Plus b and plus c. So what they mean is you just need to find a, you need to find b, you need to find c. Then when you're done, you'll come back and substitute it or plug it into this formula and get a formula that you can work with. All right. So now that we know that my 2a is equals to what? Is equals to 2, which means my a is equals to 1, because I'll divide by 2 both sides, right? Okay. And then now my b, which would be 3a, remember 3a plus b is equals to that. 3a plus b is equals to 7. And I know my a is 1 plus b is equals to 7, therefore my b is equals to 4, because 7 minus 3 will give me a 4. So you see, you have your a, which is 1, your b, which is 4, your c, which is, we're yet to find out. A plus b plus c is equals to 3. A plus b plus c is equals to that. A, which is 1, b, which is 4, c, which is the unknown, is equals to 3. 1 plus 4 is 5. C is equals to 3 minus 5, which is equals to negative 2. All right, negative 2. So now you just do the substitution. So therefore, my Tn is equals to a is 1. So this is just n squared plus what's my b? 4n minus 2, because my c is 2. There we go.